Hi, my name is Paul Fisher. I'm a professor and extension specialist at the University of Florida, IFAS Extension. And I'm glad that you can join me today to discuss 5 tips on the use of phosphorus fertilizers. And this is a topic I really strongly believe in because many growers unintentionally are over applying phosphorus and polluting our environment. So in this video, we'll show you how you can play your part to help the planet while improving your crop quality and perhaps even saving on some fertilizer cost. Now, there's a lot of myths around applying extra phosphorus fertilizer, that it will help boost flowers and fruits and root growth on our crops. And I'm going to try to fight those myths with some science. So I'll present research from a lot of very smart scientists and fertilizer experts who show over and over again that extra phosphorus is not needed. And I especially thank my colleague, Dr. Jake Schreckheis from USDA ARS for his help in this presentation. Now, the biggest reason to reduce phosphorus is because it encourages algal blooms in our natural waterways and irrigation reservoirs through eutrophication. And this can lead to fish kills, toxic algae, and clogging of your irrigation system. And only 30 to 60% of applied fertilizer, when scientists have measured uptake of that fertilizer by the crops, is actually used by our crop plants. So that means that up to 70% of what we apply is wasted. And the costs of phosphorus fertilizer are rising. However, growers will often apply extra fertilizer because unfortunately, fertilizer is cheap relative to the other costs in production. And that's only because our growers, we don't pay the full environmental cost of runoff if that phosphorus leaves your greenhouse or nursery. And another sustainability issue around phosphorus is that phosphorus is a limited resource. Most of the fertilizer comes from mined rock phosphate from areas such as Florida, where I live. And phosphorus use is increasing as our global population increases. And that means there's not only more use of this limited resources, but there's also potential risk of environmental damage from mining and disposal of the waste products. So we have myths about using phosphorus fertilizer, and phosphorus even has a mythical origin story. And Hennig Brand was an alchemist in the 1600s, and he was in search of the philosopher's stone, which could change base metals into gold. And he noticed this enticing gold color of urine and thought that might be the key to the philosopher's stone. And so he had funding from a couple of rich wives, and after processing a lot of urine later, his experiments left a substance that would glow in the dark and burn in the air. And so, of course, it wasn't the philosopher's stone, but he had discovered this 13th element, the devil's element, which was named phosphorus, which is based from the ancient Greek for the bearer of light. And the elemental symbol of phosphorus is, you guessed it, cheesy chemistry joke here, P. So one use in the plant is to convert sunlight energy into chemical energy for biochemical processes within the plant, the conversion of ADP to ATP with sunlight. And phosphorus is an essential element for plant growth. And if phosphorus is limiting, just like with any other essential factor, then plant growth and yield will be limiting. And we call this Liebig's law of the minimum. And the classical appearance of phosphorus deficiency is purple or red leaves, but there are lots of other reasons why you get this purple or red leaf color. And so it could be, for example, cold or excess light, or a nitrogen deficiency. So don't just apply extra phosphorus fertilizer if you see red leaves. First, you can confirm that by sending a sample off to a lab for a tissue analysis to confirm the level of phosphorus. Now, some plants show phosphorus in other ways in terms of deficiency. So on the left picture, for example, you see these phosphorus deficient violas are just not growing. There wasn't any phosphorus in the pre-plant fertilizer charge or applied after planting. The azalea tips at the top show browning from low phosphorus rather than the red color. And if phosphorus deficiency is mild and not extreme, then you might just see less growth and smaller leaves like you see on this hydrangea at the bottom right. And phosphorus deficiency can occur for various reasons. One of them, of course, is we're just not applying enough phosphorus fertilizer. Or if the soil is cold, then there is less active uptake of phosphorus by plant roots. And phosphorus solubility is also affected by soil pH. My good friends, Dr. Bill Argo and Dr. John Birnbaum, did this work at Michigan State University, and Bill is now a leading fertilizer specialist with transplant growers around the US. And Dr. Birnbaum is a professor emeritus who's an expert on plant nutrition and organic farming. And they looked at phosphorus availability, meaning soluble phosphorus, phosphorus that's available for plant roots to take up in a peat-based growing medium or substrate. And they saw that when the pH in the substrate is above 6.5, so as we're starting to get more basic, then phosphorus reacts with calcium to form a solid, a precipitate that's not so available to plant roots. And in field soils, when the pH is low, then there is also the potential to tie up phosphorus because it can react with aluminium, and iron. And so that is another situation where at low pH in a field soil, we can tie up our phosphorus. So in field soils, there's a sweet spot around pH 6 for maximum phosphorus availability. Okay, so why then do some growers over-apply phosphorus? It's based on some myths. Myths that extra phosphorus can promote or steer the plant towards flowering, fruiting, and rooting. And so growers will boost the phosphorus sometimes at planting or at fruiting and flowering to try to get that effect. We already saw that phosphorus is an essential nutrient. So plants need enough phosphorus for healthy growth, but unfortunately, any extra phosphorus does not lead to these plant benefits. Fertilizers are often described in their NPK ratio. And I'm going to get into a little bit of detail here. And it's because of history that in the US and some other countries, the ratio in that NPK fertilizer labels are actually N for nitrogen, P2O5 for phosphate, and K2O for potash. And we'll explain later why these oxygens and the phosphorus and the potassium are important, because they add weight without adding the elemental fertilizer. So a high phosphorus fertilizer has a high middle number. For example, 10, 54, 10 is 54% by weight of that fertilizer as phosphate. And the mythology around extra phosphorus, in this case for Bloom Plus, is that if we add extra phosphorus, that we're going to get, in this case, extra flowering, but really it's more of a marketing tool than a reality. So does extra phosphorus really increase flowering? Well, unfortunately, the answer is no. So let's take a look at where scientists have actually measured how much phosphorus is needed for flowering or foliage ornamental plants. And Dr. Josh Henry is a scientist at a leading US company designing retail fertilizers, and he did his PhD with Dr. Brian Whipker at North Carolina State University. And Dr. Whipker has written hundreds of articles. He's really the leading expert about nutrient deficiencies in our ornamental and other crops. And in their research, they added different amounts of phosphorus from a water-soluble fertilizer. And so with each time they irrigated the plants, they added between 0 all the way up to 80 parts per million of phosphorus, along with all the other plant nutrients at non-limiting levels. So they were trying to see, where did phosphorus start to become limiting. And you can see that flowering of petunia was the same at 10 parts per million of phosphorus or higher. And there was no benefit above 10 parts per million of phosphorus for vinca flowering or for irisine growth in these examples. And they concluded that depending on the crop, anywhere from 6 to 13 parts per million of phosphorus in a water-soluble fertilizer is adequate if we apply that with each irrigation for a very wide range of annuals. And later in this video, we'll give examples of low phosphorus fertilizers that would be able to deliver this number of parts per million. Okay, so how about a fruiting crop? Well, this was research work by my colleagues Wendy Wilbur and Jeff Williamson from University of Florida. And they showed that extra phosphorus does not increase fruit yield in blueberries. And they tried two different granular fertilizers, a low phosphorus, high potassium formula, and also a high phosphorus formula. And both fertilizer types led to the same plant growth and fruit yield. So adding extra phosphorus, I'm afraid, did not boost the yield in blueberries. But how about maybe phosphorus level is higher in the plant, in the fruit or the roots, which is another claim target for extra P, compared with the leaves and the stem? Well, Dr. Bruce Bugbee at Utah State University is a brilliant plant physiologist. He's worked with NASA and has many years of experience with hydroponics and other types of crops. And he showed that no, in tomato crops, the fruit and the roots are in fact not a special sink for phosphorus compared with leaves. There was similar phosphorus level across different plant parts. Now, if we talk about tomato, then it's true that if you apply very high levels of nitrogen, there's going to be a lot of growth of leaves, vegetative growth, but low fruit counts. However, a couple of our other leading nutrition experts are Dr. Neil Matson of Cornell University and Dr. Carrie Peters of J.R. Peters Lab, and they reviewed the literature of different fertilizer recipes that are available for a range of hydroponic crops. And this summary here in the table shows that the phosphorus levels in a typical tomato program are actually similar during the fruiting or reproductive phase compared with the leafy or vegetative phase. So the key to steer tomato crops, plant morphology, towards fruiting is to drop nitrogen level as opposed to increasing phosphorus. Well, how about another claim of increased P, that high P increases rooting? Now, Dr. Paul Nelson is a professor emeritus at North Carolina State University, and he has probably published more articles than anyone else about fertilizing greenhouse crops. And he's the author of the leading greenhouse textbook used in US university classrooms. He is an expert. And Dr. Nelson showed that when you reduce phosphorus, then it's important to think about P, phosphorus, relative to N, nitrogen. Dr. Nelson's research showed that if you want to favor rooting over shoot growth, avoid over-applying nitrogen and choose a fertilizer that has low P relative to N. High P leads to leggy transplants, and low P leads to a more compact transplant. And so commercial growers use this information all the time to produce transplants. And if you look at seedlings that are being grown, seedling plugs, where we want a nice compact transplant with strong roots, then they'll have a low nitrogen level and they'll have an even lower phosphorus level. So they'll use a fertilizer such as 13-213, a plug type special fertilizer, which actually has low phosphorus to cause some limited shoot growth. So your transplant crops are not going to benefit from extra phosphorus. And if you don't believe the scientists, then just follow the lead of huge young plant greenhouse growers that I work with who use low to moderate nitrogen and also low phosphorus to grow hundreds of millions of compact and well-rooted transplants every year. Now, it is possible to apply too little phosphorus to transplants and also during the growing on phase with flowering plants, because phosphorus is an essential nutrient after all. Dr. Alison Justice is now a leading cannabis researcher and entrepreneur, and Dr. Jim Faust at Clemson University is an expert in floriculture plant physiology. And they showed at Clemson University that you can easily apply the small amount of phosphorus that is needed, either with 12 parts per million of phosphorus on these New Guinean patients with each irrigation after planting, which we can see in the top row, or you could add some phosphorus, incorporate it into the growing media before planting, and then you would need even less phosphorus to add during crop growth. And of course, if you did not add any phosphorus before planting or after planting, then yes, there'd be limited growth and lack of flowering. But a little bit of phosphorus from either strategy resulted in beautiful New Guinean patients. And again, there was no benefit of going all the way up to 24 parts per million of phosphorus. So we've talked about ppm, or parts per million. So we're going to dive down a little bit into units. We often describe concentration of dissolved ions like phosphorus and nitrogen in a nutrient solution, water-soluble fertilizer, in terms of ppm. So let's take an example of that 10-54-10 high phosphorus fertilizer we discussed earlier. If we prepare a nutrient solution with 100 parts per million of nitrogen, it's going to have 236 parts per million of phosphorus. And we can relate that back to the images we saw before. If we increase the overall concentration of this fertilizer to 200 parts per million of nitrogen, it's going to have even more phosphorus. It's a blended fertilizer. It'll have 472 parts per million of phosphorus. And recall that the examples that I've shown you so far only needed somewhere around 10 parts per million of phosphorus to provide the phosphorus needed for growth and flowering of many floricultural crops. So if you used 10-54-10 in order to provide a moderate rate of nitrogen at 100 parts per million of nitrogen, you would be way over applying phosphorus, way more than the plant can use. So that extra phosphorus is just going to go down into the growing media and potentially get leached away into the environment. So an annoying detail, unfortunately, about these fertilizer labels that makes things more complicated to do these calculations is that you have to convert from N-P2O5K2O into this elemental P and K. And so thankfully there's an app for that. It's on my website, Back Pocket Grower, under Tools, and the app is called Convert NPK and N-P2O5K2O. So 100 parts per million of P2O5 or phosphate is only equal to 44 parts per million of phosphorus, elemental phosphorus. And also you do a calculation to decrease the K2O level. So you can enter in a fertilizer label into the calculator app in backpocketgrower.org, and it will calculate the ratio of elemental N, P, and K in a fertilizer solution at 100 parts per million of nitrogen. If you do those conversions with different N-P2O5, K2O fertilizers, then you can see that 10-54-10 and another high phosphorus fertilizer, 20-20-20, are going to over apply phosphorus at only 100 parts per million of nitrogen. So if you wanted to be in the sweet spot of around 10 to 20 parts per million of phosphorus for most crops, then a low phosphate fertilizer like 15-5-15 is completely adequate at 100 parts per million. Now, this is up to now talking about water-soluble fertilizers and parts per million, but many nursery growers use solid controlled release fertilizers with crops such as woody ornamentals that are in containers, and maybe they're outdoors and getting rained on, and it's easier to apply the fertilizer in that way. And this research team of Dr. Jake Schreckheis, Jim Owen, and Alex Niemera at Virginia Tech University studied different N-P2O5, K2O ratios for hydrangeas and hollies, as well as other crops. And in this case, their high P fertilizer was only 15-6-12. And just remember that some growers will use a fertilizer like 14-14-14 that's even higher in phosphorus relative to nitrogen. So their control was this 15-6-12. And we can kind of think about nitrogen to phosphate ratios here, 15N, 6 phosphate. So it's around 3 nitrogen to 1 phosphate, about 3 times as much nitrogen as phosphate. And all of the fertilizers were standardized to the same amount of nitrogen per plant. They were incorporated into our growing medium. And if the phosphorus levels were really low, with a very low phosphate fertilizer like 18112, then yes, phosphorus did limit growth and flowering. However, compared with the control, they could still easily drop to a ratio like 18:3:12 and still produce great flowering plants. Okay, so there is never a reason in these woody ornamental crops to be applying 14:14:14, 12:12:12, 10:10:10 on a routine basis. So cannabis growers, it's a major emerging crop now. And unfortunately, they've brought a whole new range of myths with them as they've brought their crops out of the closet into the sunlight. And what might have worked in a basement makes no sense when we scale it up to a pharmaceutical and industrial scale. For example, one myth is that high levels of phosphorus, sometimes even over 100 parts per million of phosphorus, are needed during cannabis flowering. Thankfully, we have a lot of researchers now challenging those myths and doing high quality research work on cannabis. And Dr. Nurit Bernstein and her colleague Sivan Shaponi are among those researchers, and they've consistently shown that 30 parts per million of phosphorus is adequate during both vegetative and flowering stages with cannabis in terms of yield and potency of cannabinoids. So no, cannabis, I'm afraid, is just not that special. In field crops and field soils and landscapes, in fact, most of the phosphorus is not in the form of soluble phosphate, and it is rapidly bound up in organic matter and in minerals like aluminum phosphate at low pH and calcium phosphate at high pH, like we mentioned earlier, and also from natural weathering of mineral rocks. So often there is adequate phosphorus in the soil for plant growth, even without adding any fertilizer, especially if over the past few years, there have been applications of high phosphorus fertilizer or manures. And in many areas that are sensitive to phosphorus runoff and algal blooms, such as urban areas in Florida, regulations require that you can only apply phosphorus fertilizer in this landscape and turf if there is a proven deficiency from a soil test or a plant tissue analysis. And look at it this way, you're getting free phosphorus supply if your soil test shows high P. You just don't need to apply anymore. So why is it that we hang on to these myths and we find it so hard to change? It isn't just with phosphorus fertilizer, but we humans are just stubborn. We would rather deny new, uncomfortable information than reshape our worldview. And when doubts do creep in, we just dig in our heels. And we have to go through a grief process of denial, anger, bargaining, depression, until we finally reach acceptance. And we love myths. There are simple ways to explain the world. For example, we think we're in control if we can steer our crops to fruit, root, or flower just by applying extra phosphorus fertilizer. And I'd make a quick shout out to a website called informationisbeautiful.net, and it lists some great myths and challenges them. For example, Napoleon wasn't short. He was actually of average height for his time. Bulls don't see red. They're actually colorblind. And I'm sorry, but you can't actually see the Great Wall of China visible from space with the naked eye. Okay, so we love these myths, but let's turn to science-based recommendations on phosphorus applications. And I've given plenty of scientific proof from some leading researchers and also leading growers that there are best management practices that will save you money, give you better crops, and help the planet. So avoid runoff of extra phosphorus, use soil and tissue analysis, not just color, to diagnose a deficiency, provide nutrients in the ratio that plants can use, and at the levels that the plants can use. So we saw that was up to about 10 parts per million in plugs, and many annuals. 15 parts per million would be a high level for most flower and foliage crops, and we might need up to 30 parts per million in cannabis. So don't use 20-20-20 or 14-14-14 on a routine basis. And if you're a landscaper, then do a soil test to see if you need any phosphorus at all. And if you don't believe me, which you probably don't, then run trials and just check if you switched, like in that research project from Virginia Tech, try changing to a different fertilizer and see what the results are in your case. So if you'd like more information on topics like this, then we have various websites and resources. One of them is the website I manage called cleanwater3.org with information about water quality and water treatment and water conservation. We have online courses and our greenhouse training online program designed especially for growers. And I'd like to thank our sponsors for this YouTube channel, the Floriculture Research Alliance. So click on subscribe below, and I hope you learned something about the myth of phosphorus today. Thank you.